Projectile motion. So we start by the definition. Projectile motion is the motion of an object that has been thrown into the air and allowed to fall freely under the influence of gravity. So you could use the words thrown, projected, launched, any of those words. So under projectile motion, there are three kinds of pathway the object goes through, or three types of motion. No, not three kinds of motion though. So we can throw an object vertically upwards, so it goes up and comes back that same way. At maximum height, the velocity is zero because we threw it with a velocity, but when it gets to its maximum height, its velocity is zero, and then it begins to fall back down under the influence of gravity. And then we also have this, we are at a certain height or a platform and we throw an object. We call that horizontal projection. We throw an object horizontally. So this is the platform. We throw an object horizontally. So it falls going through this pathway to get to the ground. Now in this case, we see two motions, a vertical motion, that's its downfall, and a horizontal motion, which we call the range. So for this, we note that the horizontal motion is totally dependent on the speed or velocity with which we threw it, that initial velocity with which we threw that object. The horizontal motion is totally dependent on it. And then the vertical motion it went through is totally dependent on acceleration due to gravity and independent on the velocity with which we threw it. Okay, so now the third case is when we threw the object from maybe the ground floor at a certain angle to the horizontal. So this is the floor. So we threw that object with an initial velocity at a certain angle. So the object goes through this pathway, this parabolic pathway. So we also notice two motions the object undergo. A vertical motion, it went up, and a horizontal motion. So in this case, we now see that we have an angle. So, and that is what we'll be looking at in this video. We'll now be looking at projections at an angle to the horizontal. And in case you were given the angle to the vertical, all you just do is 90 minus that angle to the vertical, because what we work with is angles to the horizontal. Okay, so we now have a maximum height and we have the range, which is the horizontal distance that object covered. Okay, so we also have time. So we have vertical motion, horizontal motion. We also consider the time. There is the time taken to get to maximum height and then the time taken to fall back. Both of those are equal. So the time it takes to get to maximum height is equal to the time it gets to that same plane with which it was projected. So that time, the total time that object does this motion is called time of flight and is denoted with capital T. So the time of flight is the time a projectile spends on air from its plane of projection back to that same plane. But if we talk about another time, maybe time taken to get to maximum height, we use a small letter T. So we get into examples to see how to calculate this kind of projectile motion. An object is projected with a velocity of 80 meters per second. So let's start writing out our parameters. So initial velocity is 80 meters per second at an angle 30 degrees to the horizontal. So angle theta is 30 degrees to the horizontal. Remember, you always make sure that the angle you calculate with is to the horizontal. If it was stated that it's to the vertical, you just say 90 degrees minus whatever angle that was given. That is when you now get the angle to the horizontal. That is what we work with. So we have to calculate the maximum height and all these other parameters. So first, we now see maximum height is equal to u square sine square theta over 2g. So this is the formula. You have to memorize it and get used to how to use it. So the initial velocity 80 squared times sine 30. This sine square theta means the sine of that angle squared over 2. And of course, we are given acceleration due to gravity as the constant 10. So when we've done our calculations, or let's just break it down. So we have 80 times 80, and then sine theta is half times another half, and then over 20, that is the 2 times 10. So we have this cancels out, this into this is 4, 2. So what we have left is 80. Therefore, the maximum height attained is 80 meters. Okay, so the second thing we have to solve for is the time taken to reach maximum height. So this is not the time of flight, just time, we have time. Time taken to reach maximum height is u sine theta over g. Now, if it was time of flight, it would have been 2u sine theta over g. That's 2. Further emphasize the fact that the time taken to get to the maximum height is also equal to the time taken to fall back to the projection plane. Therefore, time of flight is 2u sine theta over g. But if you are just asked for half of the time, no need for that too. So we have 80 times sine theta, sine 30. We are substituting now over 10. So this cancels out. Sine 30 is half. So half of 8 is 4 and 4 seconds. So this is B, this is A. And then to solve the third one, the time of flight. No need to use this formula again since we've solved this. So we have that the time of flight, capital T, is 2 times the time taken to get to maximum height, which is 2 times 4 seconds, which is 8 seconds. And then finally, we solve for the horizontal distance, otherwise known as the range. So range, capital R, or we just spell it out, range is equal to u squared sine 2 theta over g. So that is 80 times 80 sine 2 times 30. So this should be in a bracket, sine 2 times 30, or when you spread it out, that's 60. Okay, so when we solve, we get that the range is equal to 554.26 meters. Okay, so that is it. We go to further examples. In this example, we have that an object is projected with a velocity of 100 meters per second from the ground level at an angle theta to the horizontal. If the time of flight of the projectile is 10 seconds, calculate that angle theta. And of course, we are given that acceleration due to gravity is 10 meters per second square. So let's write out our parameters. So the velocity of throw, initial velocity, 100 meters per second. And we have that the time of flight is 10 seconds. And we have that g is 10 meters per second squared. And the angle of projection is what we are to find. So we have time of flight, that's the formula we are to use. Time of flight is equal to 2u sine theta over g. We substitute. So when we substitute, we have that t is 10 is equal to 2 times 100 sine theta, looking for that, over 10g. Okay, so we have 20 and 10, and then this gives us 2 times 10 is 20, so we have 10 over 20 is equal to sine theta. And when we have find that half is equal to sine theta, and we know that the angle that is equivalent to, that is, whenever the sine of an angle is half, we know that that angle is 30 degrees. Or let's say it's not this simple or popularly known angle that you found here. All you have to do is sine inverse of whatever thing that is on this side, 1 divided by 2. That is what you have here. And then when you've done that, you get 30 degrees as the angle. So that is it. So let's look at another example. A football is kicked at an angle 45 degrees to the horizontal over a defense line up with a velocity of 15 meters per second. Calculate the magnitude of the horizontal velocity of the ball at its highest point. This is just a little bit different from what we've been doing before, but let's write out our parameters and understand the question. So the angle of projection is 45 degrees. Okay, with an initial velocity, the velocity of projection is 15 meters per second. And what we've been asked to calculate is the magnitude of the horizontal velocity of the ball at its highest point. So ux, that is the horizontal velocity. And it's also important for us to note that under this projectile motion of an object that goes through the full parabola like this, that at maximum height, vertical velocity is equal to 0, and the velocity is actually equal to the horizontal component of the velocity. And as we go up, the horizontal component, the vertical component of the velocity keeps on reducing till we get here, and then keeps on increasing till we get back to the projection plane. Okay, but that aside, we know that vertical components of vectors like this velocity is equal to the vector cos the angle of inclination to the horizontal. So that is, the vector now is the velocity of throw, the speed of throw, and this is the angle to the horizontal. Okay, so we have it to be 15 cos 45 degrees, and we now have it is equal to 10.61 meters per second. So that's it. You see that handling this kind of motion is actually very easy. All you have to do is to memorize the formulas if you don't have a formula sheet with you. So just memorize the formulas, know how to use them. When we have sine squared theta, it's equal to sine theta squared. I think that's, and then when we have sine 2 theta, that is 2 times the angle. That's where we usually have challenges when using the formula, because some people don't know how to apply that. Okay,